Before we built cities, before we shaped landscapes, before any form of life looked up and wondered, an invisible architecture was already here. A structure older than stars, older than time as we perceive it. It stretches across the universe like a silent web, holding galaxies in place, guiding matter without ever revealing its face. Tonight, we follow the threads of that hidden architecture, the structure beneath everything, the quiet force shaping the cosmos. At first glance, the universe appears chaotic. Stars scattered, galaxies drifting, space is expanding endlessly. But scientists discovered something that changes the way we understand all of it. The universe isn't random. It is arranged, structured, threaded together by something we cannot see, but can measure, and increasingly can map. Astronomers call it the cosmic web, a vast network of filaments made not from stars or planets, but from something far stranger and more elusive: dark matter. It doesn't shine. It doesn't absorb light. You cannot touch it. Yet it forms the skeleton of the universe. Every galaxy, including the Milky Way, is anchored to these hidden structures. A galaxy does not choose where to form. It forms where the cosmic web tells it to. Where filaments cross, galaxies gather in clusters. Where filaments thin, galaxies disappear into the dark. It is as if some invisible blueprint dictates where everything belongs. These voids are not empty by accident. They are empty by design. The design of the unseen architecture beneath the universe. But how do we know something invisible is shaping the cosmos? The answer is movement. Galaxies are pulled as if by ghostly hands. They rotate faster than they should. They cluster in patterns gravity alone cannot explain. Something is guiding them, something powerful, something silent. In the 1970s, astronomer Vera Rubin first measured these motions. What she found changed cosmology forever. Galaxies were spinning so quickly that they should have torn themselves apart, yet they held together. Something was holding them. Something invisible. Something that doesn't break, doesn't fade, and doesn't collapse. This invisible force is what scientists now call dark matter. But the term is misleading. It isn't dark. It doesn't even matter in the ordinary sense. It is something else entirely. Perhaps a new kind of particle, perhaps a field, perhaps a property of space-time itself. We still don't know. Yet its influence is unmistakable. It creates the scaffolding for galaxies. It shapes the observable universe. It holds everything in place. Imagine this filament as a river, not of water, but of gravity. Matter flows along it. Gas sinks into its channels. Stars ignite in its deepest valleys. Without these rivers, galaxies would never have formed. The universe would be a thin, dim fog. No planets, no suns, no life. The silent structures beneath the universe make existence possible. But this raises an even deeper question. If the universe is structured, if there is a blueprint, then where did the blueprint come from? Was it born at the moment of the Big Bang? Was it carved by quantum fluctuations? Or did something older shape the cosmos before space itself expanded? To understand the architecture of the universe, we must go back to its earliest moment, to a time when matter did not yet exist, when forces were not yet separated, when the universe had no form, only potential. What happened in those first fractions of a second might explain why the cosmic web exists, why galaxies gather where they do, and why we are here at all. To understand the invisible structures that shape the universe today, we must return to a time when nothing we recognize existed. No stars, no particles, no space wide enough to hold a galaxy. Only a newborn universe, smaller than a single atom, but expanding faster than anything we can imagine. In the very first moment after the Big Bang, the universe was smooth, almost perfectly smooth. A hot, dense sea of energy without shape. But this smoothness did not last. Something deep inside this early universe shifted, creating tiny bumps and ripples. These tiny ripples were the universe's first blueprint. Scientists now believe these ripples came from quantum fluctuations, tiny, unavoidable changes in energy that occur even in empty space. Normally, these fluctuations appear and disappear instantly. But during the early universe, space was expanding so fast that these fluctuations were stretched, frozen in place. They became permanent. Think of it like this. Imagine ripples forming on the surface of a pond. Normally, they fade. But now imagine the pond is suddenly stretched in all directions faster than the ripples can disappear. The ripples become frozen into the surface. This is what happened to the universe. These tiny variations in density, some areas slightly thicker, some slightly thinner, became the seeds of all structure. Where the density was a little higher, gravity pulled matter inward. Where it was a little lower, matter drifted away. These early ripples decided where galaxies would one day form, and where great cosmic voids would remain empty. But something else was present, something that responded even more strongly to these early ripples: dark matter. While normal matter was interacting with radiation, colliding, heating, cooling, dark matter simply followed gravity, quietly, directly, without losing energy. Dark matter rushed into the slightly denser areas, piling up faster than normal matter could. It formed small gravity wells, and these wells grew. They extended like threads, connecting to each other across enormous distances. These threads were the first filaments of the cosmic web. Over time, normal matter began to fall into these dark matter wells. Hydrogen formed, then helium. Gas collected, pressure built, and in the deepest pockets of dark matter, the first stars ignited. These pockets grew into galaxies. Galaxies gathered into clusters. Clusters linked into superclusters. And all of it followed the pattern created by those first tiny fluctuations. The universe we see today, every star, every planet, every galaxy, exists because of these frozen ripples from the beginning. So when we look at the cosmic web today, we aren't just seeing a structure. We are seeing a memory, a preserved imprint of the universe's earliest moment, a map of the ancient fluctuations that shaped everything. It is the closest thing we have to the universe's birth certificate, a document written not in ink, but in gravity. From nothingness came patterns. From patterns came structure. And from structure came the stars. But the cosmic web is not only a relic of the past. It is alive, evolving, changing. Let's explore how these silent structures continue to shape galaxies right now, including ours, and what they may become as the universe grows older. What are the gravity's hidden pathways? The cosmic web is not a static relic. It did not fade after the universe formed. It continues to shape the cosmos right now, in every direction we look. Galaxies may appear to drift freely, but they follow invisible paths. Currents carved by dark matter, channels sculpted across billions of years. To understand the present-day universe, we must follow these currents and see how the web still guides everything. Galaxies are not isolated islands. They sit inside enormous halos of dark matter, invisible spheres that cradle the galaxy like a protective shell. These halos are not round or simple. They stretch and twist, connected to the cosmic web like beads on a vast string. The cosmic web exerts gravity. Its filaments pull galaxies along their length, guiding their motion. Even across hundreds of millions of light years, galaxies respond to these gravitational threads. Galaxies migrate toward intersections in the web, places where filaments meet. These intersections grow into massive clusters. You can think of a filament as a highway, but one without roads, signs, or barriers. Instead, galaxies follow the highway because gravity gives them no choice. They flow from emptier regions into denser ones, just as rivers flow downhill. The shape of the cosmic web decides that path. But galaxies don't just move along the cosmic web. They grow because of it. Filaments carry gas, cold streams of hydrogen stretching for millions of light years. This gas flows into galaxies like nutrients feeding a living organism. When these gas streams reach a galaxy, they ignite the birth of new stars. Without the cosmic web feeding them, many galaxies would stop forming stars entirely. In fact, astronomers now believe that galaxies receiving strong filament streams remain active and bright, while galaxies cut off from the web slowly fade into darkness. This might explain why some galaxies appear ancient and quiet, while others, even of similar size, glow with new life. The difference is simple: connection to the web. But the web does something even more surprising. It can determine how galaxies spin. Galaxies do not rotate randomly. Along thin filaments, small galaxies tend to spin with their axes aligned to the filament, as though the web twisted them into position. Larger galaxies, however, behave differently. They often rotate perpendicular to the filament, as if their mass breaks the flow and flips their orientation. This pattern is not random. It is the fingerprint of the cosmic web, written into the spin of galaxies across the universe. And this hidden influence is not somewhere far away. It affects us too. The Milky Way sits inside a filament. It is not floating alone. It is part of a long, faint thread that stretches millions of light years, connecting us to neighboring galaxies like Andromeda and beyond. Our galaxy is slowly moving along this filament, drawn toward a larger structure called the Virgo cluster, and beyond that, toward something even more massive. The cosmic web is guiding our motion right now, silently pulling us across the universe. So when we look at galaxies today, their shapes, their paths, their star-forming life, their direction of rotation, we are not just seeing isolated systems. We are seeing the influence of invisible threads, gravity's hidden pathways. The blueprint still working, still shaping, still deciding the fate of galaxies. In the next section, we follow these pathways into the future to explore what the cosmic web is becoming and how it may evolve as the universe ages and expands. So, what becomes of the cosmic web? The cosmic web has shaped the universe for more than 13 billion years. It guided the birth of galaxies, fed them, shaped their motion, and defined the large-scale design of the cosmos. But the universe is changing, expanding, accelerating, and everything shaped by the web is drifting farther apart. What becomes of the cosmic web in a universe that refuses to stay still? To understand the future, we first need to understand the force responsible for the universe's accelerated expansion: dark energy. While dark matter holds the web together, dark energy gently pulls it apart. For billions of years, gravity and the web's structure worked together. Filaments pulled galaxies inward. Clusters grew. The universe formed large, organized patterns. But dark energy works the opposite way. It stretches space itself. Not from the inside of galaxies, but between them. The result is slow but unstoppable. Imagine the cosmic web as a giant net. Every knot is a galaxy cluster. Every line is a filament connecting them. Dark energy is pulling on this net from all directions, slowly widening the gaps. The knots remain tight and strong, but the lines between them begin to stretch. Over the next tens of billions of years, the cosmic web will continue to evolve. Filaments will still feed galaxies, but less effectively than before. Gas streams will thin. Star formation will slow. Galaxies will grow older, redder, quieter. In the distant future, the expansion of space will become stronger than the pull of the cosmic web. Filaments will stretch so far that galaxies will no longer feel each other's gravity. The web will remain, but it will grow faint, thin, quiet. Clusters of galaxies, like our local group, will stay gravitationally bound. The Milky Way, Andromeda, and a handful of satellites will merge, forming one giant galaxy. But beyond this island, the night sky will slowly empty. This is the destiny of structure in an expanding universe. Clusters remain. Filaments thin, voids grow, and the cosmic web becomes a set of isolated islands floating in a dark ocean that grows more silent with time. Eventually, trillions of years from now, the web's lines will stretch so far that their influence becomes undetectable. The large-scale pattern will fade from view. But the memory of the web will remain everywhere, in the way galaxies formed, in the shapes they took, in the stars still burning inside them. This is the future written by the cosmic web, a universe shaped by invisible forces, then slowly stretched by the acceleration of space itself. The web is both creator and witness. It lit the first fires of star formation, and it will accompany the last galaxies as they drift into the dark.